Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for choosing IT Pro TV, helping you learn wherever you go. I'm your host, Zach Memis, for CompTIA Net Plus, and this is going to be Ports and Protocols this episode, and the person who's bringing us all the information we need is the one and only IT expert himself, Wes Bryan.
Hey, how you doing,
barely get that one out.
Yeah, there we go. Well, I tell you, it's great to be here, and that's right. We're going to be looking at, well, some communication types, right? Ports and protocols. So, before we dive into all the various ports and protocols that we have to look at, let's just kind of step back for a second and let's break down what a protocol is, all right? When we look at a protocol is nothing more than a structured set of rules for communication. And we have different communication types, different services, different applications that, well, need to make communications across our networks today, more specifically our TCP IP-based networks. And in other chapters or other episodes, we will talk more about something known as the Transmission Control Internet Protocol model, right? The TCP IP model is responsible for moving traffic along the internet. Well, we need to know what services, what protocols, I should say, certain services are going to use. So that's what we're going to look here in this episode at. Now, the next thing I also want to talk about are ports. All right, the protocol is a rule for communication, and it means that if you're going to use that form of communication, both the source and destination of the communication have to be using the same protocol, right? We don't really mix and match. So, for instance, if I'm going to send email, right, from my client, the application that is sending that email is going to send it out a certain port. Well, guess what? On the other end of that communication, that protocol and port have to be the same, or we're not going to get that intercommunication, right? Ports, if you will, are a logical identifier, right? What they do is they logically identify what's known as an endpoint of a connection, right? So again, if I'm going to send communications from my host machine, let's say my laptop, to an email server, right? How do we identify that that is coming from me? Well, we associate that with a transport protocol, which we're going to talk about in this episode, as well as an IP address, and then identify the traffic with a port number that's associated at the end. Now, I do want you to understand that when we talk about ports, we've got a series of ports that the IANA, the Internet Assigned Numbering Authority, today it's ICANN, the International Corporation for Assigned Names and Numbers, have basically just allocated for different types of services, right? And they're basically broken up into three categories, right? We have what is known our well-known ports, all right? Our well-known ports are 0 to 1023. And inside of these ports, if you will, we identify all of our common networking services, all the communication types, things like DHCP are in this range, things like what you're going to see here, SSH. All of these commonly used services fall under this port range. Now, the next port range we have is 1024, again, 1024, all the way to 49151. And these are what are known as registered port ranges. And registered port ranges are certain applications and services. Companies would go to INA, and INA would allocate them for their different services, right? Now, the registered port range, you will see, sometimes is used for applications such as things like, for instance, remote desktop protocol. A remote desktop connection, if you will, software inside of Windows that's been in Windows for a very long time, right? That uses something known as port 3389, and you can see that Microsoft, when you, let's say if you were to identify that type of traffic out on your network, we could see that port 3389, if we have that traffic traversing our network using things like protocol analyzers, we know that it's associated with a protocol known as RDP. All right, now the last range is that 49152, that's right, 49,152, all the way up to 65,535. Don't worry, I don't have any of these individual, well, a few of them I have memorized, and you're going to have to memorize some of them for the exam, but you don't have to memorize all 65,535 ports, right? But that port range, again, as a recap, 49,152 to 65,535. These are ephemeral ports, if you will. They're temporary ports. Sometimes you'll hear them called dynamic port range, the private port range, if you will. And this is a way, basically, computers will use these ports just to set up a communication so that we can identify the endpoint of where that communication is going. And then once the communication is done, they get reserved, basically thrown back over in that large pool. And your computers, again, they use them dynamically. So that's kind of why they've got a few different names, dynamic, private ports, if you will. Dynamic because of the fact that My computer might be using one of those ports now, and when that port closes down, well, guess what? It could use a completely different port after the fact. All right, they also call them ephemeral ports or temporary ports, if you will, because, again, they associate the endpoint of the connection. Once those ports are used, they're not necessarily associated with really any type of communication. And you can see all different types of computers and devices using them today. And once they're no longer needed, they go back over into that pool. But nothing in that pool specifically is typically reserved by our internet standards bodies within that range. So the 3 range is, again, a well-known port range. We have the registered port range, and last but not least, we have the dynamic port range. These ranges are going to be important for you to know on the exam because they might give you some of these ports that we're going to talk about here in this episode. And essentially what they're going to say is, what port range is that in? And it's going to be up to you to understand and know and identify those on the exam. All right, so with that being said, let's talk a little bit about the protocols that we have that we need to be aware of for the Net Plus exam. The very first one, all right, I'm going to talk about. I'm actually going to kind of go out of order here on this one, Zach. Throw Zach a curveball. I'm going to write down my notes, and then I'm not going to use them at all, right? So, and there's a reason here, because one of the first ones that they call out is something known as Secure Shell, SSH. But I'm going to skip down the list, and I want to talk about another one here, and that's something known as Telnet. The telecommunication networking protocol, if you will. Telnet. Telnet's an oldie but goodie. It's been around for on the internet before the internet was even the internet. It goes back to the days of ARPANET. It's been around since the 70s, and it is again a tried and true protocol that allows you to make a remote logon to another computer, to another host. And what I mean by that is I have a computer right here, and I need to connect to another computer, and I need to be able to issue commands against it.
Now, Wes, I know you're terrific with history. Was it called Telnet because of telephone, Telnet? I mean, was that involved with that or no?
Well, a little bit, but not the telephone, just the telecommunications part.
Okay.
So that side could be, you know, because a phone is telecommunications
I
as
remember
well.
in high school we had the huge computer room and I heard phones in cradles and things like that.
Well, this goes back to those days, and let me go ahead and expand on that because I know that back when you had like 5 people connected to ARPANET, right? I say 5 people, 5 entities, universities, and military. I would listen to stories of some of the guys that are in Silicon Valley as now when they were going through university and saying, hey, I'd love to jump on that ARPANET with Telnet and control that remote computer, right? And that's what it's for. It's for a remote logon. It goes over what is known as port 23, and I want you to remember that. So if I have a protocol analyzer and I want to find out what type of traffic, what kind of communications are going on the network, and I see there's traffic bound for port 23, I know it's going to be a Telnet communication. Now, oldie but goodie, Telnet, when those days, because there wasn't in the early days of our internet working communications, there wasn't a lot of necessity for privacy, excuse me. And why is that? Well, because in those days, you didn't have a lot of people connected to networks, right? But this is well past the dot-com boom. That's long since not been true. And that's one of the drawbacks to Telnet. Telnet, as a terminal emulation software, it sends its information in plain text, right? And what we mean by plain text or clear text, as we'll talk about a little bit of security in these, through Network Plus as well, is the fact that let's say I'm sending commands to, and Zach, we're gonna play a little make believe here, right? I'm going to send communications to Zach, right? And I'm going to do it with Telnet, and I'm going to issue some commands. Maybe it's a file transfer, or maybe it's just, a remote command on it. Not really a file transfer, but maybe it's just a remote command on that machine. The problem is if I'm sending communications like that to Zach and it's set in plain text, somebody could be out here on the sidelines and they could be scraping that information and gathering it, doing packet capture, and they can see all of the information that is in that type of those type of packets, right? So it's a security vulnerability. And that leads us into our one. I've got one up here on our computer, and this is something known as SSH. And that's why I wanted to kind of preface SSH, just talk about Telnet prior to SSH. Because today's day and age, we need encrypted communications. We need secure communications, right? So for instance, let's say that I'm going to issue some commands against maybe a switch or a router, right? I don't want Zach to be able to be out there, and if I'm doing this in Telnet, be able to scrape that information and see the configurations, the configuration database, any of that information that I'm issuing against something like a router or something like a switch, if you will, something like a server, right? But if we use SSH, the secure shell, and we connect to port 22, what we're doing is we're actually sending an encrypted communication, and it goes through an interesting process. Very basically, what you have is you have a client. Remember, these are client-server protocols, and if I probably should have said that too. And in services, we have clients that are requesting a service through these protocols, and the servers are actually out there listening for that incoming communication. Just remember that clients, like we've talked about in other episodes, a client is a computer that requests resources from another computer. A server is that computer that provides those resources. So there's a client initiation in SSH. It means, hey, I need to connect, right? Well, what happens is the server or the device on the other end that's providing that service that you're going to connect to, what it does is it sends a public key. We'll also talk about asymmetric encryption in other episodes as well, but for now, and if you're not aware of that, go check out some of our public key cryptology, right? It sends a public key. And then from there, what we do is my computer, now that I've got the server's public key, we can generate these session keys. They call it a symmetric key. It just means that there's one key versus asymmetric, which is two. And then I generate that session key, and I encrypt it with the server's public key. Now, the only key that can unencrypt that information is the server's private key. Well, there's a reason it's called the private key. Only the server has it. So when I send that encrypted package back over with the session key, essentially what the server can do is basically strip off that encryption, see the secret, a session key that we've sent, and now from here on out, we're going to send encrypted secure communication, and my client can log on and then can also issue commands after that fact. So SSH is a very good protocol when you need to make a remote logon, and you don't want anybody else to know what's going on. You don't want anybody else to eavesdrop on that information. It allows us that confidentiality that we talk about in the CIA triad, the three principles of security: confidentiality, integrity, and availability. Remember, confidentiality is done through encrypting your information and not sending it over a network in clear text. All right. Oh, and let me make one mention of something else about SSH. There's a couple of versions of SSH. The first one is considered vulnerable. It has some security vulnerabilities, so they have SSH version 2, and that's what you should be using today. And again, the old one isn't really good. I always write down in my notes, version 1's bad, version 1 or 2 is good, and that's just because in version 2, well, one of the things is that they have this enhanced key exchange that just makes it a little bit, a lot of it more secure, if you will. All right, so that's SSH. All right, now the next thing that we need to know about is what is known as DNS. Now, when we look at DNS, and we'll talk more about the DNS hierarchy, Zach, in other episodes, understand that we just want to know the protocols and their ports in this episode, because there's a lot more to DNS than what I'm about to tell you, but you'll get the basics here for now. Just knowing that, well, domain name system, right? So if we can look at my computer here, right? So I have what's known as a DNS client. The DNS client basically sends out a resolution request, says, hey, I have this name and I can't find the IP, right? That's what DNS is responsible, taking those names and mapping them to IP addresses like we'll talk about or have talked about in our DNS episodes, right? So what happens is my computer, the DNS client, says, hey, I need an IP, or I've got a name, and I need you to resolve that to an IP address so that I can communicate with it. In this case, we're using www.google.com, right? So when I launch up my web browser here, right? I launch up my web browser, and I'm going to do a search, right? It's not my web browser, but that my web browser needs to know how to find Google, right? And how does it find Google? Well, it basically sends out a name resolution request out to, in this case, could be your internal company server. If you're in a home network, then you probably don't have a DNS server on your local network. You're like, I didn't install a computer. Well, that's going to be your ISP's DNS server, right? And what your home router is going to do is you're going to say, oh, you need a name request? Let me go ahead and send it out to your internet service provider, and they'll provide you a name, the IP address. So that's basically what's happening here, right? Essentially, a client request is sent to the DNS server, all right? Now, the DNS server goes through this process, right, where it says, I don't own Google. Well, let me go ahead and let me send you out to Google's DNS server. And another process, again, like I said, it's a little bit more complex than that, but for the basics, it's happening over port 53. So when name requests, resolution requests through DNS happen, they happen over port 53. All right, now from the server side, this is just the client side. From the server side, what happens is in this case, let's just say Google's DNS server says, oh yeah, I could find, I know where www.google.com is. You could find it at this address. And it responds back to, in this case, the company DNS server or your ISP's DNS server. Google's DNS server responds back and says, guess what? You can find www.google.com at this IP address. And again, the big thing here, the big takeaway is that it's port 53. That's our DNS port, all right? And we get our answer back, and the answer is delivered back to the original client who asked the question. And again, this is over something known as UDP. Now, I haven't mentioned user datagram protocol, and I haven't mentioned transmission control protocol. So we'll just put the brakes on that one, and we'll come back to that at the end because it is important to understand those two transport protocols, all right? Now, we also have a series of file transfer protocols, if you will, right? There's been quite a few of them over the years, and one of them that has been around just as long as Telnet is the file transfer protocol, right? FTP. FTP is another one of those oldie but goodies, and it's still kept around because it's highly optimized for large file transfers. All right, so if we could take a look at my screen here, file transfer protocol is a weird one in the fact that for the most of these protocols that we talk about, you're going to see there are a couple of exceptions to that. It typically has a single port, all right? Not so with FTP. FTP is one of those ones that's a little bit more greedy. It takes two ports. And what we mean by that is when I need to initiate and, let's say I need to connect to a file transfer protocol server, an FTP server, and I need to upload or I need to download a file, I have to initiate the command that starts that exchange, whether it's pulling that file down to my local computer or sending it up to the FTP server. And when that happens over port 20. Or excuse me, I'm sorry, port 21. Let me be specific. We'll get those wrong on the exam. Port 21. So the commands that I issue to tell the FTP server what I'm going to do, that goes over port 21. Now, when the data exchange happens, again, remember, file transfer protocol, you could be sending it up to the server or what they say, pulling the file down to maybe your local client. That's going to happen over port 20. So keep in mind, two ports. And I always remember this on the CompTIA exams when I was taking it, data over commands, right? 20, 21, data over commands. That was just something that I did. Again, use your memorization techniques on this one because, well, unfortunately, when it comes to the port numbers, it is just sheer memorization. All right, so that takes care of one of those protocols. Now, FTP, just like Telnet, also has a vulnerability. Again, because when FTP came out, understand that we didn't have a lot of entities on the backbone of the internet, let alone it even being called the internet at that point. So, what's its issue? Just like Telnet, it is a clear text protocol. Plain text, right? That means, again, if I'm loading a file, maybe it's a sensitive document, and I'm loading it up or transferring it up to the file server, well, guess what? If Zach's out there with a protocol analyzer, he can be out there scraping that information, and guess what? He can break down those layers of the OSI model, and he can potentially see the information that's in there and gain access to the data. So what we want to do is we want to go a little bit farther with our file transfer protocol, and there's something known as SFTP. All right, now be careful, all right, SFTP. Sometimes you'll see it abbreviated, you'll see other abbreviations, I should say, that look just like it, right? SFTP is Secure File Transfer Protocol. But there's also an old one called Simple File Transfer Protocol that's completely obsolete. I don't want you to worry about it, but it's got the same darn acronym. We're not shy of acronyms here in the NetPlus series. The other one that I also want you to know about is you could see it, if they're not talking in the context of protocols, screen foiled twisted pair. This is basically a type of category cable for Ethernet networks that has a lot of shielding in it, and sometimes I've seen it abbreviated that way. Just want to help you out with your acronyms. What we want is Secure File Transfer Protocol. So what is happening? Remember our little protocol we started out with, SSH, how it encrypts communications between endpoints to do things like remote logons? Well, guess what? We set an SSH tunnel up and we connect to that FTP server. That's it. We pulled the blinds down on anybody that's going to be trying to gather our information. So if we could take a look here, an SFTP client starts what's known as an SSH tunnel. All right, and that's that encrypted tunnel, no different than SSH. And then when we connect, all of the information that we're either transferring to the FTP server or pulling down from the FTP server now becomes encrypted. And guess what? It's great for confidentiality. It means, picking on Zach, Zach, you've been a good sport so far. Zach's our hacker, and he wants to get access to that information.
Ethical hacker.
That's right. That's right. Well, we'll remind it. Zach's got his white hat on, not the black hat, right? But and all seriousness, though, keep in mind you want to be using something like SFTP. Now, FTP and SFTP, these are connection-oriented services. All right, and FTP has a lot of overhead in the fact that you can issue commands, you can transfer files, but sometimes what you need is just a very simplistic way to send files across the network, right? And that's the other one I want to talk about. And if I didn't mention it, SFTP uses the same port as SSH, so port 22. And Zach, I absolutely love that when you can remember 2 ports, 2 protocols, and the ports are identical. SSH, and if you need to remember SFTP uses SSH, so you can remember it also uses its associated port. Now, sometimes, like I said, even as highly optimized as FTP is, right? Sometimes you don't need those commands. You just need a really quick, minimalistic way to send things like even small firmware files or config files, if you will. And that's where something known as Trivial File Transfer Protocol comes in. Now, this is a little bit different because what it uses is something known as User Datagram Protocol, right? So it's a little bit more streamlined, a little bit faster, and it doesn't have the overhead, if you will, network overhead, communication overhead as FTP. So know that Trivial File Transfer Protocol, again, it's a stripped down version that runs over the User Datagram Protocol, and it uses port 69, all right? So important stuff to remember there. All right, so that takes care of a handful of the ports that we need to talk about. I think the last one, Zach, looks like we got enough time. We might have to go into a part 2 on this one that I want to talk about are the email protocols. And the email protocols are important, and they are important to understand because even if you're not going to be, let's say, a networking guru, all right, we definitely want you to be a networking guru, and if you're going to go into a networking position, you're definitely going to have to know these. But even from basic client configuration on the email side, you're going to have to know these ports. All right. And if we could take a look at the screen here, I've got one of the first ones I want to talk about. All right. This is known as SMTP. All right. This is another one of those email protocols. Been around for a while, right? This is what's known as the Simple Mail Transfer Protocol. All right. Now, I want you to pay attention to the direction of the arrows, right? Because this is one that you might overlook if you're not paying attention, close attention, all right? Sometimes I get these arrows out here and it looks nothing more than like a roadmap to downtown New York. But in this case, what we're talking about is we're actually sending information outbound to the server, right, over port 25. Simple Mail Transfer Protocol is responsible for forwarding traffic from a client to a server. And the other thing I want you to understand too is notice that we have an SMTP server here and an SMTP server here as well. Well, why do we have SMTP being forwarded between servers, right? Well, guess what? Servers also use port 25, and when they're sending SMTP, that means they're forwarding traffic. So if company A has an SMTP server and company B has an SMTP server, guess what? From server to server communication, rather than just the client, a little piece of software running on my client here, they're also going to use port 25, all right? So port 25 for sending email, SMTP. All right, and the reason I make mention of that is because that is in a contrast to the next one here, Post Office Protocol version 3. I don't know what the heck happened to version 2, but we've been on version 3 for a while now. Post Office Protocol version 3 is what POP3 is. Now, notice the direction of the arrow in this one. All right, it's a little bit different here. All right, this is for retrieving email. All right, this is for downloading your email. POP3, and I'm always going to say POP v3, but POP3 is what I would use to connect to an email server, pull the email or retrieve it, pull the email down from the server to my local hard drive. Now, I do want you to understand that POP3 has a specific port as well. All right, if you're going to connect to a POP3 server, you're going to be connecting on port 110. Again, remember, identifying the endpoint of the connection, right? That's what those ports are there for. It is retrieving email, though. There is one thing that you got to worry kind of about. There's a little concern over POP3, and that's the fact that when I download or when I connect to my POP3 server or a POP3 server and I download my email, guess what it does? It erases the copy of that email off of the server. Now, that doesn't seem like a big deal, all right, because we're so used to using the third email protocol, which we'll talk about here in a second, that we don't think about it, right? If you think, Zach, I don't know if you're like me, but I use Gmail a lot, or I use Office 365, and it doesn't matter where I go to log in, I have access to my email, right? Well, with a POP3 server, let's say that you're at home and you connect to your company's POP3 server and you download your email and it's got a copy of some important statistics that you need to present to your boss, right? Well, when you connect to that POP3 server and you download or retrieve your emails, it erases those emails from the server, and then you go to work. Come into work and you connect to the POP3 server, and guess what? Those emails are gone. You downloaded them locally to the client when you first connected. Now, I do know, and I am aware, that there is an option to leave a copy up on the server, but that's one of the drawbacks to POP3. All right. Now, if you want to be able to manage your emails on the server, and you want to work with them, create folders, doesn't matter what computer you go to, that's where you're going to use, if I can say that right, don't lose. That's where you're going to use the last email server or email protocol that we want to talk about here. And what I've got here is an example of what is known as IMAP. All right, that's the Internet Message or Mail Access Protocol. What this allows me to do is this allows me to connect to the server, and I can manage, download, and work with my emails just like I could if they were stored locally. And I can log into any web browser that supports it today. That's what we commonly use today, right? IMAP. And that's why if I log into Gmail, I can go to one web browser, one computer, I can look and retrieve my emails, but they're on the server. They look to me as they're local, right? I can see them in the web browser, but then I can go over to another computer and I can log in. I can connect to that IMAP server, and guess what? Still have access to my email. All right, so 3 of the email protocols. Oh, and the last one there, IMAP, that's port 143. All right, so we've got port 25 for SMTP, we've got port 110 for POP3, and we've got port 143 for IMAP. Keep in mind your email protocols, and Zach has given me the old evil eye when it comes to this time, so it does look like we're going to have to put a comma in this episode and come back with a part 2.
Well, you do a fantastic job, and it's amazing everything that you remember, and you're able to share it with us so fluidly. Thank you so very much. And so, of course, this is Ports and Protocols Part 1. There'll be a Part 2, and this is inside the CompTIA Net Plus series. Make sure you watch every single episode. Course library, hundreds of videos are there, and they're all designed to help you go further. Check that out, too. And tell everybody you know about IT Pro TV. They'll be very happy you did. Thanks for watching. I'm Zach Memis.
And I'm Wes Bryant.
And we'll see you soon.
Thank you for watching IT Pro TV.